it's Sarah, your instructor from Anthropology 2201. Today we're going to talk a little bit about one of the ways we determine how old an artifact is. We're going to talk specifically about radiocarbon dating. Radiocarbon dating is extremely important to archaeologists because it provides us with an approximate date range of how old an organic material is. So as opposed to relative dating, this is absolute dating. So let's take a second and explore how radiocarbon dating works. Organic materials are living things like people, plants, and animals that participate in the processes of respiration, the act of taking in oxygen and expelling carbon dioxide, or they participate in photosynthesis, the act of using light energy to process carbon dioxide and water. Plants are integral to the formation of radiocarbon. During the process of photosynthesis, they take in carbon dioxide from the atmosphere and release oxygen. During the release of oxygen, the carbon isotopes get stuck or fixed to the plant tissue. Plant tissues have tons of carbon. Animals, such as rabbits, primarily eat plants. When the rabbit eats a plant, he too will take in carbon isotopes that will fix to his tissue. Radiocarbon is formed all the time in the atmosphere. The atmosphere is made up of a multitude of nitrogen and oxygen isotopes. Radiocarbon is created when cosmic rays bump a neutron into a nitrogen atom, causing it to release a proton. The atom then becomes carbon-14. C14, or radiocarbon, is unstable carbon. Stable carbon, like C12 and C13, usually has 6 protons and 6 or 7 neutrons, while C14, or radiocarbon, has 6 protons and 8 neutrons. Radiocarbon, or C14, is unstable because it decays. If a plant keeps up with the process of photosynthesis, it will continue to fix carbon. But when it dies, the carbon-14 starts breaking down over time, converting back to nitrogen. The decay rate of radiocarbon is constant. Every 5,730 years, the dead organic material only has half as much radiocarbon as it did when it was living. This period is known as radiocarbon's half-life. We can see in this image how the amount of radiocarbon in the organic material decreases by half. There are special machines called accelerator mass spectrometers that can measure the amount of C14 isotopes in a sample by specifically isolating them. Decays, C12, or stable carbon, does not. We can measure the amount of C14 to C12 to determine how much radiocarbon has decayed. We can see in this graph, as the stable carbon stays at 100% in the sample, the radiocarbon, again, decreases by half. We can also use calendar dates to compare radiocarbon concentrations. Calendar dates can be obtained from tree ring data. Tree rings are laid down about every year. We can look at the patterns of tree rings to determine how old a tree is and to identify periods of drought and other climatic events that can then be lined up with known dates. The tree rings are essentially mini calendars. Some trees, like the Bristol cone pine, that grows in the western United States can be old as 14,000 years. Tree ring data can then be used to calibrate radiocarbon dates. In this image, we are looking at a calibration curve. So we can take the amount of C14 in a sample, which we see on the left axis in this graph, and the calendar dates obtained from tree ring data, which you can see at the bottom axis. Additionally, we can find trees with the same amount of radiocarbon and line them up with the sample. The amount of radiocarbon in this sample is displayed in the blue line running across the graph. From this data, we get a range of dates that appear in the gray histogram circled here. The higher the curve of the histogram, the older or the more accurate the sample date is. So from this sample, we can determine that it was about 3,000 years old, plus or minus 30 years. So there's a 87% probability that this sample was created around between 1320 BC and 1129 BC. There we have it, the radiocarbon dating process. It can get a little confusing and complicated, but it's still useful to know about. So now that we know a little bit about the process, I want you guys to take a second and think of what items from an archaeological site that we can radiocarbon date. What are those organic materials? List at least 3 items in the group discussion for extra credit. See you guys next week.